Hello everyone, welcome to day 3 of summer workshop. Today's topic is circle theorem. Since it is a theory topic, before beginning with the question, we will go through all important theorems which you must know. So the first one is angle in the same segment are equal. You just need to understand what is the meaning of segment. So here this thing is called as segment from A to B. So AB is a segment which is subtending an angle at any part of the circle, which is x, and there will be infinite of such possibilities. They all will be equal. That is the meaning of first rule. Next is opposite angles of a cyclic quadrilateral are supplementary, that is they adds up to 180. Now for a cyclic quadrilateral, only thing which you must know is all four vertices should lie on the periphery of a circle. If it is somewhat like this, then it is not a cyclic quadrilateral. This is a very common mistake. So just remember that the one which I have drawn is not a cyclic quadrilateral. Okay, it is not. Next is angle at the center is twice the angle at the circumference. So let's say AB is an arc. This is an arc which is subtending an angle 2x at the center. So it will subtend half of that at any other part. There will be once again infinite possibilities which should begin and end with A and B respectively. Next is rule 4, where if we have a perpendicular from the center, that will bisect the chord. So AB is a chord and this line OD is a perpendicular from the center, it will bisect the chord. Okay, normally this is used as a direct result for questions if required. Next is radius and tangent are perpendicular to each other. So angle between radius and tangent is 90 degree. P is called as point of contact. Red one is a tangent and the green one is the radius. Angle between them is 90 degree. Next, from one external point, which is B as per this diagram, there can be maximum of two tangents which can be drawn, and they both will be of same length. Next, angle in a semicircle is right angle. So semicircle means you can see that AB is the longest chord and that's why it becomes a semicircle, and this angle will be 180, so half of that will be 90 degree. Okay, there will be once again infinite possibilities. You have to just observe. Last one is alternate segment theorem. The angle between tangent and the side of the triangle, so this is side of the triangle, and tangent is equal to the opposite interior angle. So opposite interior angle, so this is how it works. Okay, alternate segment because this is one of the segment and the angle is present in another segment, so that's why it is called as alternate segment theorem. Okay, you should just observe the diagram carefully. If it is alternate segment, then angles are equal. Now we'll just see few questions just to make you understand the application of these theorems. First question. In these questions, I will be mainly discussing the reasons. Okay, I will not be writing everything, but I'll be mainly discussing, so you have to listen to me carefully. So this is a circle in which ABCD are the points. They are asking us size of angle CAB. CAB is this. Okay, if you look at the arc BC, this arc BC is making an angle of 42 with respect to the circle. So the same angle 42 will be for this as well. So I can say that angle CAB will be 42. Then comes next part, angle ACD. ACD, this is ACD. Okay, so if you remember the theorem, angle in the same segment are equal, then this will be 81, reason angle in the same segment. Then work out size of angle AEB. AEB is this angle, which can be obtained by using 180 minus sum of these two. Okay, so just use that and you will get the answer for angle AEB. You can use calculator for this. So on solving, the value of AEB comes out to be 57. Then comes the next one, size of angle BEC. BEC is this. You can use a linear pair, so this will be 180 minus 57 and that will give me 123. For all parts I have spoken the reasoning. Since they were of just 1 mark, we don't have to write the reasoning. Okay, we can just write correct answer. You'll get full marks for writing correct answers. And the last one is 123. We can move on now. Now here ABC are points on circumference of a circle with center O. Angle ABC is 79. Work out the size of angle CAB. We need to get this angle, but we know that it's a semicircle, so angle in a semicircle is 90 degree. So we can use angle sum property and get the third angle. So by 90 plus 79 plus angle A is equal to 180. On solving, you'll get angle A as 11. That's it. And the reason is angle in a semicircle is 90 degree. Angle in semicircle is 90 degree. And angle sum property. Next question. Here we have to find size of angle COB. Angle in the same segment are equal, while angle at the center is twice the angle at the circumference. That's the theorem we'll be using. So this is 29, so this will be twice of 29. Reason is that theorem, and that we can mention it in the second part. Next question. Here you can see that ABCD is a cyclic quadrilateral, and we can use that theorem of cyclic quadrilateral to get size of angle ABC. ABC is this, which will be opposite to 96. So that will be 180 minus 96, and that will be 84. Then for the next question, write down size of angle OCB. OCB is straight away 90 degree because radius and tangent are perpendicular to each other. That's the reason we will write. Next. Here we have to find size of angle ABC. Now for finding size of angle ABC, first we need to find the central angle. Central angle will be twice of 68. So that will be 136. Then this side OC and OD are radius, that's why it will become an isosceles triangle. You can use angle sum property for triangle ODC and get these two angles. Sum of all of them is 180. So x plus 138 plus x is equal to 180. On solving, x will be 22. Okay, now look at 45 plus x. It is opposite to angle B. So I can say that 45 plus 22 plus angle B is equal to 180, opposite angles of a cyclic quadrilateral, and from there you can get angle B as 180 minus 67, that is 113. Angle B is nothing but ABC, and that is how we are done with the question. Next question. In this question, if you observe carefully, we have an alternate segment present. Okay, so alternate segment looks somewhat like this. So this and this angle, this and this angle. That is how you have to see. So that will be 53. Now we need to find size of angle ABC. ABCD is a cyclic quadrilateral, so somehow if we get this angle, then opposite angles are supplementary. We can get that very easily. Okay, so by angle sum property in triangle ADC, I can get 53 plus 84 plus angle D is equal to 180. That will give me angle D as 43. And then angle B will be 180 minus 43. That is 137. Okay, you can mention all reasons properly in words. I'm just showing you the working and the idea about how to solve them. Next, here we have to find size of angle ACB. Means this. So first we will get the reflex angle. Reflex angle means 360 minus 130, and that will give me 230. And then this angle ACB will be half of reflex angle AOB. Okay, it will be treated as AOB only, but reflex means the other way out. So that will be 115, and reason will be angle at the center is twice the angle at any other part. Next question. Here we have AB and CD parallel, so we can use that as well. Okay, this angle is given as 79. If they are parallel, then I can take these two as x. Reason will be alternate interior angle. Then sides are equal, AB and BD. So it's an isosceles triangle, that's why that will be 79. Now since the lines AB and DC are parallel, so angle A and angle D are co-interior angle, and co-interior angle are supplementary. So by doing that, I can get x value. X value on solving comes out to be 22. Once I got x value, I can try to find DBC. DBC, this is 22, this is also 22. Let's say this is y. So I can say that angle D, which is 79 plus 22 plus 22 plus y, angle B, is equal to 180, because ABCD is cyclic quadrilateral. So on solving, we can very easily get the value of y. That will come out to be 57, and that's it. We are done with the question. Then comes last question for the video. We will join OC. OC and OB are radius. That's why it will be an isosceles triangle, and you will get that as 27. Now because of that, you can get the central angle also. Central angle will be 180 minus twice of 27, that is 54. Okay, 180 minus 54 will be 130, 126. Okay, if this is 126, then half of 126 is angle BAC. They were asking BAC only. You can get it like this. So here we are done with the practice on circle theorem. Just make sure that you watch this video again if you have problem in any of the circle theorem. Also try to solve more questions from your side. The more you'll practice, the more clarity you will get in the topic.